Welcome, everyone. This is our September monthly Kube Chat. Today, we will be covering the future of AI efficiency. Kubecost enhances GPU monitoring. So we'll be digging into lots of details about GPU monitoring in general, but then also some fun features that we're releasing to support this. Going into the agenda here, we'll go with a quick introductions to our speakers and Kubecost. And then we will dive right into GPU monitoring, understanding GPUs. We'll cover our new NVIDIA GPU monitoring feature, as well as a sneak peek into some upcoming releases that you all can be expecting. And we'll also save some time at the end for a Q&A. We did get a number of pre-submitted questions, so we'll start with those. But if you have any additional ones that you have throughout the duration of the session, feel free to just go ahead and add them to the Q&A feature located in your Zoom webinar. And we'll cover as many of those as we can once we get to the end. And I did want to just do some quick housekeeping that we will be recording this webinar today. So if you cannot stay for the whole thing, don't fret. We will send a recording to your email right after this call. You should be expecting that email from myself. And I'll also send a copy of the slide deck for everyone, just so you have it handy. And feel free to forward that to any other folks on your team that couldn't join. And with that, we'll go ahead and jump into the intros here. So in case you're unfamiliar with Kubecost, we started in early 2019 as an open source tool to give developers visibility into their Kubernetes spend. Now fast forward to today, we're helping thousands of teams across the globe, from tiny startups to big enterprises. We help them keep an eye on their cloud costs and cut out on waste. So whether you're using hybrid, AWS, Azure, GCP, or even running your Kubernetes on-prem, we're really just your one-stop shop for getting that full picture of your costs. Today, we manage about $3 billion in cloud spend. We work with some really awesome customers like Johnson & Johnson, Audi, and GitLab. Also, in case you missed the big news, I did want to mention that we are excited to announce on Tuesday we were acquired by IBM. We'll be joining their FinOps suite, which will include us along with Cloudability and Turbonomic. This acquisition is really going to help us just provide an even better product and support experience for you all. And it will allow us to massively expand our cost monitoring expertise and join forces with some fellow leaders in the FinOps space. So we're very excited about what's to come with that. It's still very new, so we don't have a ton of information to share, but I promise we'll be sharing as much as we can with you as it all starts rolling out. Now I wanted to give you an introduction to our speakers. So we have Joe today. He's our principal product manager here at Kubecost. He has an impressive background. He has, over a decade of experience working in the tech world. He's done cybersecurity, cloud computing, and fintech. He's also developed lots of products that have delighted millions of customers and users, including folks at FedEx, Amazon, Microsoft, Apple, you name it. He's probably touched it. And I dropped a link here to his LinkedIn. So if you'd like to connect and talk about all things product or product marketing, feel free to reach out to Joe. He's your guy. And then next we have Chip. So Chip is our product manager here at Kubecost. He also has a ton of experience in the cloud native space. He's been working in the industry for over a decade. He's also a very prominent contributor to the open source community. So if you have any burning questions about Kubernetes, Chip is your man. I also dropped a link to his LinkedIn here. So if you want to connect and talk shop, he's more than happy to talk with you. And with that, I'll go ahead and pass it over to our speakers for the day.
Thanks so much, Dee. Pleasure to be with you, Chip. And for everybody in the audience, thank you so much for attending. Hope today is informative and a little bit fun and opens your eyes to some of the important new developments in this space, like AI and machine learning and the use of GPUs and how you can kind of wrangle costs and manage efficiency and understand your utilization of those things better. So we'll jump right in with some updates. If you've been living in a cave for the last 3.5 to 4 years, AI is ubiquitous. It's a chat agent in every new software tool that you're using. It's quite literally coming to iPhone and other handheld devices tomorrow. It seems to be absolutely everywhere. And the things that are powering AI and machine learning, this new revolution, are GPUs. They've really kind of become the new backbone of modern computing. And that's because they're designed to handle thousands of simultaneous processes, unlike traditional computing resources. And that makes them really indispensable for things like training highly complex AI models and doing it rather quickly. As the demand for AI solutions just continues to skyrocket, so does the demand for GPU hardware. Businesses are leveraging AI for everything from customer service chatbots to really advanced scientific data analytics. And this kind of surge, this massive and quick growth are really reflected in basically every market projection that you could think of. So AI as an industry is expected to grow with a CAGR of over 20% in the next 3 and 4 years. In 2024 alone, you can take a look at the blue bar under or over 2024 there. The market for AI products is expected to eclipse $185 billion. That's just a huge amount of money. What's even wilder, though, is that GPU spending is expected to exceed $300 billion in 2024 alone, with NVIDIA taking about half of that. That means if we think we're already swimming in AI and machine learning solutions and development, you've seen nothing yet. It's just going to get crazier. With this growth comes some really big challenges, though. First and foremost, managing and monitoring GPU resources effectively. These are scarce pieces of hardware. You can't just go down to the store and buy as many of them as you'd like. In fact, the largest companies in tech are jockeying for allocations of these GPUs and competing with each other to get their hands on more and more. Without kind of proper oversight, we risk continuing a trend that we've already started here, which is overspending and underutilizing. So it's really critical that we get this right. There's a lot of challenges, though. It's not so easy to monitor GPU usage and manage their costs. It's even more difficult than some of the more traditional compute resources that we've all become accustomed to in the cloud native space. One of the biggest challenges is just the flat lack of visibility into GPU utilization. It's another black box that's really difficult to see inside of. And without really robust monitoring tools, we're essentially flying blind. We can't see what GPUs are actively working. We can't see which ones are idle. We don't understand whether they are being used efficiently or not. And it's this kind of obscurity that leads us to make uninformed decisions, speculations, and to improperly allocate resources, especially when trying to scale those systems up. So, simply put, you just can't optimize operations without knowing how your resources are being used. It's basically impossible. The second challenge is that it's really difficult to attribute costs to specific workloads. AI and machine learning tasks, they frequently involve multiple models and multiple data sets all running concurrently across various GPU resources that you've got. And if you can't track those things, you can't accurately assign costs of GPU to projects, products, experiments, things like that, departments and teams. This leads to things like budgeting issues. It makes it really hard to identify which workloads are driving up costs, which ones are being utilized effectively and efficiently. And then finally, there's a real risk of inefficient GPU usage leading to massive overspending. I think over the last few years, there's been essentially blank checks that have been written to get AI at the forefront and to deliver solutions that are powered by ultimately GPUs. And there hasn't been much scrutiny on the costs that are associated with that. But those costs can really add up. They can really impact your bottom line, reduce your return on investment for the hardware spend, for the utilization of cloud resources. And that can really hamper your AI initiatives from a business level. So this lack of visibility and cost attribution, it leads to inefficiencies. And ultimately, it results in a loss of money and in some cases, an inability to compete against others that are maybe doing it more effectively and efficiently. We can go ahead and go to the next slide. Let's not get too ahead of ourselves. When I last purchased a GPU, it was so that I could play like a AAA video game that was coming out, right? I remember 2004, I bought the most expensive GPU I thought I would ever buy so that I could play Doom 3. But it's become such a different thing now, right? These aren't just used for rendering graphics. GPUs at their core, no pun intended, are specialized processors, and they're designed to accelerate graphics rendering. But the key feature of them is their ability to do parallel processing, right? So unlike CPUs that have just a few cores that are optimized for doing some sequential tasks, GPUs have thousands of smaller cores, and they're able to handle a multitude of tasks simultaneously. The real fundamental difference is that GPUs can process really complex computations much more efficiently and effectively than CPUs. And that has a lot of context when it comes to AI and machine learning. So they're used for training neural networks. They're used for handling vast amounts of data, performing tons of calculations in really short time simultaneously. And they can accelerate this by doing multiple computations. So it really reduces training times for complex models from, in some cases, days and weeks down to hours. And that makes all the difference when every second counts these days. So it can be used for other things as well, right? Climate research, computational chemistry, astrophysics and spaceship telemetry. I mean, you name it. When there's a lot of data that you need to be able to chunk through and compute, GPUs have become the go-to resource for them. So why do we need to monitor these? If you want to head to the next slide. Monitoring them is absolutely mission critical. I mentioned the scarcity. I mentioned the high cost. If you're not doing a good job stewarding the utilization, efficiency, and cost kind of balance of those, you're going to have a bad time. On the performance side, monitoring allows us to identify things like bottlenecks. It allows us to see which GPUs are overburdened, which GPUs are sitting idle or not even being used at all. To optimize workloads and distribute tasks more evenly, you need to be able to understand what's going on, and monitoring really is the only way to get there. That's going to lead you to faster processing times, more efficient AI computations. From a cost perspective, it helps you understand unnecessary expenditures that you're not going to get without some monitoring visibility. You're not going to understand what's sitting idle, what's being used to their full potential. You're not going to be able to optimize things like workloads and the distribution of those workloads to be optimized in your environments. It allows you to do things like allocating GPUs to the things that are your highest priority, right? Where are they needed most? Moving less critical processes off to other resources that maybe aren't your best GPU resources. And it also helps you really scale and plan more effectively. So if you can understand from a monitoring perspective what your current utilization and associated costs are, you're going to be all the more prepared for forecasting future needs as things just continue to accelerate and accelerate. So it's essential for maximizing performance. It's essential for managing your bottom line. It's essential for understanding how profitable you are with your products. These are all mission critical things if your company is doing AI and machine learning work, and you've got to get ahead of it. So enough of the product marketing side of GPU efficiency and utilization. I'm kicking it over to Chip, who's going to talk about some cool new things that we're doing.
Thanks, Joe. So let's talk about what Kubecost can do for you when it comes to GPU monitoring. So first and foremost, before you do any understanding of utilization efficiency, you simply need to understand, where do I have GPUs? What things are even using them? Without going too far into the weeds, GPUs function, as Joe mentioned, in a pretty good way, how GPUs work. But when it comes to Kubernetes, which we're talking about Kubecost, and this is one of the, as more workloads around AI and machine learning are dumped into Kubernetes. Kubernetes is sort of the API focal point for where all these workloads are running, and first and foremost is trying to understand what GPUs that you have out there. In Kubernetes, for the most part, when workloads such as containers consume a GPU, it is 100% locked down. Nothing else can use it. It doesn't matter whether the container that is allocating or not is using it or not. So first and foremost, demystifying GPU costs. That is, how do I even see which GPUs I have in my estate? In some cases, as clusters, as we see more proliferation with clusters and therefore fewer larger clusters, you're not just going to have one cluster with one GPU. You're probably going to have multiple clusters with many GPUs. In some cases, these can be whole node groups with maybe as many as 8 GPUs per node, and also some nodes that have no GPUs whatsoever. And it's what we see is it's pretty common, in fact, to have these heterogeneous clusters. So first of all, just understanding, hey, where do I have GPUs in my estate? And then being able to go from there. And the second thing, allocating GPU spend. You're paying for a GPU whether you're using it or not, because when you're using a node, you're paying for the actual node, and that includes all of the resources that are on the node. Doesn't matter whether you're running this on premises or whether you're getting node instances from AWS or so on and so forth. So you're paying for the entire node. So understanding for the containers that are using GPUs, how am I allocating those costs? That is, taking or an understanding of what I'm spending and associating that with some sort of cost grouping. That could be a team, a product, even Kubernetes constructs such as namespace. If that's where your alignment is, what are the namespaces that are using GPUs? So it's really important to first understand those two things because everything else builds on top of them. What in my estate, what do I have as far as GPU wise in my estate? What are those costing me? Pair that up with the workloads that are using a GPU and just allocating the cost to them. But that's only the first step. And Kubecost has done that for a while now. But we got to go deeper than that. And we are deeper than that now. And that is being able to optimize GPU utilization. So now we start going a step further, which is let's introspect the containers and see not only we know that they're using a GPU, or at least that they have claimed a GPU. Now let's understand how they're using it, how much they're using it. Are they using it 3%? Are they using it 99%? For how much does the like a PyTorch job, does it spin down at night and come back up in the morning? Got to understand what the utilization is so that you can do things like identify where it's not being utilized. And this might be something like idle, what we would consider idle in Kubecost. And from there, once you have an understanding of that, you got a bigger picture understanding of your estate from top to bottom. Now you need to be able to track that over time and find out, all right, over this window, what effectively was I using and what did that equate to spend? And as you can see, the screenshot here is actually from our latest release, Kubecost 2.4. So if you didn't hear about that, this is the first version where we're introducing some of these GPU utilization related concerns. And for example, on an efficiency dashboard that we have that was released in 2.3, we're enhancing that and other areas of the product to be able to bring a notion of GPU workload and therefore idle, because now we take what we already knew about allocation of GPUs to containers and we pair that up with GPU utilization, and now we can give you a bigger picture of what things are actually using them, what percentage of the cost is being allocated to utilization, and what's being idle, and being able to capitalize the cost on that. So if we go forward from this, why did we do this? I think Joe made a lot of great points around what GPUs are, sort of what the market opportunity is, but we got to tie this together to as far as the technology is concerned. So, GPUs are everywhere now. You're probably using them if you're joining this webinar today. And if you aren't, I'll bet that you're probably considering using them soon for some initiatives that you have coming. And if neither of those are the case, I'm willing to bet that you're going to be using them fairly soon anyhow. And with all of that, like, everybody's requesting GPUs. Doesn't matter whether you're running Kubernetes on premises and you're trying to do the mad dash grab for physical GPUs to implant in your servers, or whether you're trying to negotiate with reserved instances and committed use discounts for cloud instances. Like, we've got a proliferation of GPUs that are out there. So we've got to be able to understand where these costs are going from at least the high level perspective. But these GPU devices can be really expensive as well. Some of the newer model GPUs that are coming are $30,000 to $40,000 a piece if you were to buy one outright, and that's assuming if you can buy one outright. So one of the first questions that everyone wants to know once they've already gotten some GPUs and they begin to use them is, hey, help me justify the cost of those. I need to justify. You told me as an organization that we needed to spend $1 million on GPUs for our AI initiative. Prove to me that we're getting our money's worth. So being able to cost optimize and understand this is what we have, this is where they're going, this is how effectively they're being used is mission critical. But lastly, a lot of these GPUs are really power hungry devices. I talked about some of the GPUs that are coming and what those are going to cost, but also look at the power envelope. Some of these newer GPUs can be up to 1 kilowatt. That was as much energy as a whole server used just a few years ago, and that's only the GPU. So as we are increasingly aware, and as we should be, I think, of how our computing behavior impacts the environment at large, people want to know what that impact is from a carbon cost footprint. And Kubecost already provides that today for your standard workloads, but we also want to understand, hey, how does my carbon footprint, how is that impacted by running some of these GPU workloads times all of the GPUs across my estate? So those are a number of reasons why we wanted to go further down this route to be able to give you tools that effectively help you answer these questions to your stakeholders, and also just help you get better at running your workloads at the end of the day.
Go ahead and go to the next one. Yeah, awesome, Chip. There's no free lunches, right? And I guess to continue with like Moore's law, we just have to keep feeding it more and more electricity and getting more and more carbon out of it. But one of the things that blows me away actually is a recent customer case study that we did. We have a customer called Accrete AI. They build these almost turnkey AI workhorses for customers, including the government. We were able to help them save $750,000 a year. That's, direct to the bottom line. That impacts profitability. That could literally be the difference between a company surviving in this kind of dog eat dog new AI world or not. And those are some of the benefits of what we've built and what we've brought to market here. GPU monitoring and efficiency allows us to bring FinOps strategies to the use of GPUs and the construction of AI and machine learning based products as we go forward. By doing that, we can achieve cost visibility, cost allocation. We can start to instill this kind of culture of efficiency instead of being reactive about it. By understanding exactly how GPUs are utilized and what they're costing us, we get these detailed insights. We can see which projects, which teams are consuming the most resources. It's that kind of transparency and shining light in dark places that allows us to be more effective and more efficient with everything from how we shape business entities and fund them to how we develop software and operate it. Imagine being able to say, as you were just talking about, like team A used this much, team B used that much. This product is, X% efficient when it comes to GPU utilization versus this other, and then being able to make informed decisions based on data-driven facts. That is kind of the utopian ideal that we're heading towards with these kinds of features. Waste reduction, right? By monitoring GPU usage, we identify first, where is waste happening? That's something that has been really difficult to suss out up until now. Maybe some GPUs are running, but they're not performing any tasks. They're still consuming power, as you said, right? And significant amounts of it. This allows us to right-size workloads and workflows and resources and then adjust them to match like what our actual needs are. And those things really save us money, but ensure that also our GPUs are working efficiently. These things don't have infinite lifespans. They do not grow on trees. So proper utilization is the order of the day. And
Now,
lastly, Yeah, please jump in.
I'll just add to that, Joe, that one of the what goes hand in hand with that is a lot of these multi-tenant use cases where you see more and more companies that are selling GPU and AI related services to their customers. And so, oftentimes it's not necessarily the case where we need to know all of these things ourselves. I mean, we think that that's a good thing, but if you're selling services, or if you will be selling or enhancing your existing services tomorrow for your customers around anything having to do with GPUs, you're probably using some sort of a chargeback model, or maybe at least a showback if it's internally. You need this information to be able to operate effectively your business concerns as you move forward from a multi-tenant use case. So you'll need to understand, well, what's out there using it? How much did it use it? How long did it use it? Otherwise, you don't know how much to bill, and then now you're losing money. So just wanted to throw that out there. The benefits go beyond just, in some cases, we've got a handle on that on our own internal workloads. Yes, but think about those that are selling services to your customers. You need to know this to be able to charge effectively.
Couldn't agree more. Look, we both have a long history in product. And for you product folks that are out there in the audience, either watching this live or watching this played back later, if you haven't already been approached by people in the organization saying, how much does it actually cost for us to bring on this customer, or to add 50 more customers to this product? If you don't have answers for that now, you're going to need to have answers quickly, because at the end of the day, right, we're all running businesses, and they need to be profitable, or at least not lose us lots and lots of money. Otherwise, you might be looking for a PM role somewhere else. Like, when everyone is first aware, and then secondly understands how their actions and their choices impact the bottom line, it starts to kind of foster this culture of accountability, and it encourages people to use resources more intelligently and to give it some thought. That's one of the reasons why we're driving in this new direction. It's really about shifting from this kind of reactive approach of, holy cow, look at the size of my GPU bill, to we have an idea of what we're going to be spending on GPU related costs based on our roadmap and based on the changes that we're making in the next release. So that's a great place to get to, and one that everybody needs to start paying attention to. We can go ahead and go to the next slide.
All right. So
yeah, jump on in.
Yep.
On this
so
one.
Let's talk about beyond GPUs. Obviously, that is the focus of today's webinar. But if you haven't used Kubecost before, Kubecost is much more than GPUs, right? I mean, our bread and butter is giving you deep understanding of costs that are across Kubernetes. So we need to be able to do more than just GPUs, obviously. But it's also more than just, hey, these are where I'm spending. This is where my costs are going. This is where I have idle. Like, you can make your own determinations from there on whether that's good, that's bad, if it's just high level, whether you're doing show back. But, at the end of the day, our goal is to use that not just for showing you that just for giggles, but helping you actually save money. And we want to go a step further by being proactive and giving you opportunities on where we've identified savings for you. And that's not just with GPUs, and I'll talk more about that in just a moment here, but that's across your entire estate. So optimizing more of the stack is going a step further and being proactive about identifying where you can save money, about how much money you can save, and in all the dimensions in which you can save. So the screenshot on the left that you're seeing here is our Saving Insights page, in which there are a number of cards that provide you proactive savings opportunities, both from a Kubernetes perspective, but also from a cloud spend perspective. And I'll talk in just a couple slides about how we're thinking about going forward with that in GPUs. But all of the things that you see here and what Kubecost can provide today are around more of the stack, whether it's right-sizing your instances, cleaning up orphan disks, or one of the crowd favorites, which is being able to right-size container requests based on utilization data that we see, even being able to do that automatically, which we don't have time to drill into all of that stuff today, but those are all opportunities that take us beyond GPUs that really give you optimizations in a proactive way that help you save money at the end of the day.
It is a holistic approach, right? GPUs are a new aspect of it, a new dimension to it. But Kubecost is really working to try and help you understand how to optimize and become more efficient across your entire estate, which includes GPUs now.
All right, so everybody's favorite, or probably, hopefully everybody's favorite, one of my favorites is sneak peek. What are we doing in the future? So you've heard us talk about what sort of Kubecost has on the truck, if you will, today, including some of the most recent enhancements in our 2.4 release around GPU utilization, but we're not done yet. In fact, we're really just getting started. We've got a lot more to go. Some of the enhancements that you can look forward to soon in upcoming Kubecost releases across the next several months are increased support for GPU manufacturers. So we want to be extending our GPU story today. It's very NVIDIA focused, but we want to take that forward in the very near future to extend around other GPU manufacturers, like other players in the market are AMD and Intel. And we want to be able to provide the same coverage that we do today for NVIDIA with some of these other GPU vendors. So you can expect in the future for Kubecost to be able to wrap around those other vendors' GPUs and do the same thing that it's doing today. But as I alluded to on the prior slide, one of the enhancements that's coming, and this will also evolve itself over the next several releases, but providing you GPU savings insights, just like some of the cards that you saw on the previous slide, where we're showing you savings insights that allow you to proactively save. We want to do the same thing specifically for GPUs and GPU workloads. And so in the next few releases, you can expect to see some GPU related savings and optimization insights come directly to Kubecost that allow you to not only see what your GPU utilization is, but an understanding of how you can save money. And in some cases, it could be spending money, right? If we see that, hey, there's an optimization here where, for example, maybe you aren't able to schedule workloads very effectively because of lack of GPUs, we should be able to do both. Both show you where you can save and also where maybe a spend increase is necessary to guarantee the same level of performance. And then also monitoring and forecasting enhancements want to be able to take the GPU utilization that we have today, starting in Kubecost 2.4, and augment that going forward with more monitoring and also forecasting around maybe alerts and alarms for GPU and GPU efficiency, and also maybe looking at, based on prior workloads, what your GPU needs might be 30, 60, 90 days, or maybe a year later, if that's something that interests you. So there's a lot more coming in this. And I think on the following slide, we've just got a little roadmap that sort of demonstrates that, part of all this is to help you be more efficient in your AI journey, whether you're already on that path or whether you haven't gotten started. We're committed to developing features that help you save at the end of the day. And you can see sort of a rough timeline. Don't hold us too heavily to this, but these are all things that are on our roadmap. And look, at the end of the day, we love our customers and users, and we love getting input from you. We've got a number of folks that are working with us to help co-develop what this GPU story looks like, as well as other aspects of Kubecost. But come and talk to us. What are your use cases? Are you doing something that maybe you see that your other market counterparts aren't doing? Do you have a need for GPUs that maybe is sort of strange? Are you working with existing tools today and you're noticing that there's some deficiencies that you think you'd like Kubecost to address? Come talk to us about it. We'd love to get those use cases and make sure that this roadmap that we're developing and executing on almost day by day, that it really is solving your problems and challenges that are out there. So please look us up and let's have a conversation.
Email us, team@kubecost.com. Come join our Slack resources. let's have a conversation about what we can do to solve your pains and your challenges today and moving forward. We'd love to wrap with you about that a little bit. I think we are going to jump into some Q&A now. Yes.
Yes, and we did get one pre-submitted question I wanted to get to first, and then we can move over to the Q&A in the Zoom box. But this one came from someone who is working on a self-hosted instance, and they asked, is it possible to have a different price per CPU, RAM, and GPU depending on the type of server?
Yes, so Kubecost supports custom pricing. So for those that might think that, oh, Kubecost can't really work for me, it's only for public cloud providers. Not true. Works for on-premises, and you can even define what your custom price sheet is down to the per node level and the hardware that's on that node. So yes, we've got a lot of folks that are using Kubecost in air-gapped environments and heavily restricted environments. Lots of finance, a lot of healthcare, a lot of government. And this is very commonly done. So yes, if you're using GPUs and you're running on premises, and you want to have your own custom price sheet, you can totally do that.
Got a question here from Richard, which is regarding your comment on GPU utilization. It might have been my comment. Are you saying that the utilization views the hyperscalers provide on their GPU-based EC2s are not accurate? I'll take a first crack at that, which is to say, I'm not saying that they're not accurate. They're just not detailed enough. You don't get the granular level of detail to be able to do things like allocating those costs to a namespace or to a team or to a product. You also don't get the granular data about the efficiency and the utilization. You just kind of get those bottom line numbers, which, although are very accurate, give you a pretty foggy window to look through when it comes to understanding.
Yep, and just to add on to that, and Joe kind of already alluded to it, but it's really not necessarily about showing you directly what the utilization is. It's about framing that in the context of cost. And once you frame it in context of cost, what also becomes apparent is what you're spending but not using, i.e. idle. So that's really the interesting thing here. And for most users, when it comes to GPU that relate to spend is they want to know, okay, this GPU cost, and GPUs oftentimes are the most expensive aspect of a node. This aspect of the node cost, let's say $6,000. And by the way, there are some instances available from public cloud providers that a single instance with GPUs is over $10,000. One instance with GPUs over 10 grand. How much of that is going to GPU and how much of that is being used? You only know that by pairing up that utilization information, which the hyperscalers typically aren't going to provide, even though the numbers might be accurate. You still need to understand and frame that in the context of cost, and that's what Kubecost is looking to do.
We've got some questions piling in here, so and they look like they're great ones. So first question from Paul. What are the green tech ROI implications, such as at data centers, around improving GPU efficiency in AI when using Kubecost? So we talked a little bit about how power hungry and intensive operating GPUs are. We already know that things, I think we're starting to see statistics, right? That like training ChatGPT's latest model would have powered an average town in the US for 1,000 days, things like that, right? So there's a lot of power consumption going on. Power consumption obviously comes with carbon footprint. We know how to calculate that, and we actually show that inside of our solution. So, I mean, at a high level, the implications are very high when it comes to improving efficiency in GPU as it pertains to AI, whether that's in a cloud service provider's environment that you're paying for, or whether that's in a data center or an on-premise implementation of GPUs. The implications are high.
Yep, and to sort of follow on there, for a lot of folks, and maybe some of the folks on the call here that are just starting out in your journey, it's a bell curve. Like it's a learning curve learning this new AI technology. And I can remember back in the days when some of these, more modern, more established programming language and frameworks were used, that when you start off at the bottom of the curve, you don't really know that much what you're doing. And that doesn't even take into consideration the immaturity of the technology itself. So what that equates to is maybe we don't use the technology effectively. And so specifically, I'm talking about, all right, you're a week, a month, maybe 6 months into using AI technology. Maybe just by having that information and knowing that, hey, this training job should have completed in about a day, but it's still running 2 weeks later and it's still chewing up GPU cycles. So oftentimes it's just show us what our utilization is, and that way we can understand how optimal from a code perspective we are, and therefore how unoptimal we are. Where do we need to make modifications in the code? Because this job is running far too long for the output that we're given. If you don't have an understanding of, if you don't have the GPU utilization information, and if you can't pair that with the cost, you really don't understand what the overall ROI is over the outcome, because you're looking for a specific outcome which is driven by your AI technologies. But that outcome, you may be paying 10x what you could have been paying had you known that, hey, maybe we have a model that's going off the rails here, that this should have completed very soon, but it's still running. Like, folks, we need to take a look at this and see where we need to make optimizations to bring these training times down.
One last thing I'll add on when it comes to the green tech aspect and implications here. If you're in the US or some other countries, yeah, it's still a very feel-good thing, right? To reduce your carbon footprint. In some cases, you might have a corporate mandate or a target that you're aiming for to be able to do that. Kubecost can obviously help with that with the new features and capabilities. However, if you're in a European Union country, this is no longer just a feel-good thing. This is law. And you should be aware of some of the regulatory requirements around minimizing your carbon footprint as it relates to this kind of new technology as well. Next question we've got from Paul is, can Kubecost also monitor general cloud storage and computing usage and help reduce, for example, cloud bloat? I'll let you run with that one, Chip.
Sure. Yeah, absolutely. Kubecost, in addition to obviously being, a powerhouse when it comes to deep understanding of Kubernetes costs, also understands your cloud spend. By connecting Kubecost with your cloud account, we can do a couple things that are really interesting. One is what we call cost reconciliation, making sure that what we show that you're spending, obviously it has to be after your cloud provider makes the bill available, but we can give you percent level accuracy by connecting to your cloud account and pulling down your bill. But that also gives us the ability to pull in your extra Kubernetes spend. That is your S3 instances, your RDS instances, other cloud related spend. So by pulling that in, you can see what you're spending, and also things like tags and our collections feature, which allow you to take one view and bring in both cloud and Kubernetes costs. In addition to the savings insights that I mentioned a couple slides ago, if you go take a look at that, many of those things are exclusively related to cloud spend. So what are the orphan disks that I've got out in my AWS environment, for example? These are cloud costs related spend that we can proactively identify and help you free up. So absolutely, yes, can help you both in understanding your cloud costs and also understanding how you can save on those cloud costs.
We got a couple questions here from Johan. I apologize in advance if I mispronounce your name, but exciting questions. Do you support fractional GPU? I'm not talking about MIG, but specifically a fraction of the GPU memory allocated to a container, like 10 or 50%. Is it possible to calculate the cost of the pod using this fraction for the cost? It's an excellent question, right?
Yep, good question. So for those not familiar, MIG stands for multi-instance GPU. This is an NVIDIA technology that was brought to market with the Ampere generation and forward, which allows basically a physical GPU to be partitioned into multiple, almost virtual instances. Could go more on that. I think that's a really cool technology, and there's some neat applications. When it comes to fractional GPU usage in Kubecost. So Kubecost is going to look at the overall utilization data that comes from DCGM exporter, and looking at the utilization will be able to tell you what the cost is. So if that's a fractional amount that the container is using, for example, you've got maybe your training jobs are thrashing a GPU at 100%, which is not a bad thing, by the way, but you've got some inferencing jobs that are kind of maybe hovering at 30, 40%. Kubecost is going to be able to understand what the utilization of the GPU from a full perspective, not looking at memory and how the SMs are doing, but what the utilization of the GPU is based on the container. And if it's, for example, 30 or 40%, it's only going to show you and allocate 30 to 40% of the cost to that container, not, okay, the GPU costs $5,000, making up a number. Yep, that container is using all $5,000. It's not going to do that in 2.4. Now that we're pulling in the utilization metrics, it will show you it will allocate the usage to that container. And as I mentioned, Joe mentioned earlier, that opens up the door to showing you what the idle is, which is a very important aspect as well, because then that helps you answer the question, maybe we don't need those A100s that do support MIG. Maybe we can use some T4s because we see that, hey, these A100s that we've got, they're only 30% utilized, and maybe we could go with a cheaper GPU that would drive higher utilization, therefore more cost efficiency.
And your second question was, in an environment with jobs preemption, if a job is scheduled on a different type of GPU, depending on the availability of GPUs, are you able to calculate cost on different kind of GPU for the same pod? So ultimately, kind of a right sizing question, right? Should I be utilizing a different GPU for this job?
Great question. The answer today is not yet. That's something that we're looking at. We'd like to be able to take a look at and compare different GPU models and sort of provide you like an optimization footprint of what this is currently using and what we think that you can use. It's a little bit tricky when it comes to GPUs, but it's something that we're on the case and we're looking into it, and that's something that we'd really like to be able to do in the future. And not only just show you, hey, here's a cost comparison, you can make the determination yourself, but also, hey, we've seen what the utilization is and we've tracked it over a period of time. We're going to go ahead and tell you a specific model and maybe an instance that we think that you could replace that instance with this instance and therefore be more cost effective overall. So definitely something that we're interested in, definitely something that we're investigating.
Just a quick question here from Dove. Can we get the recording of the talk and the slides? Absolutely. It's going to be sent out to everybody that registered to the email that you registered with. You'll probably see that hit your inbox tomorrow, I would say, Dee.
Yep.
Excellent. And then I'm not sure if that was a follow-on question from you on. With that fractional GPU, you can have two jobs with 50% of the GPU memory each. Essentially, yeah.
Yep. Again, when it comes to GPU, so that question, if it were phrased as a question, you'd need to use one of the concurrent access sharing methodologies that NVIDIA offers, and that could either be time slicing or MPS. And only in those two instances, again, leaving MIG aside because that's a little bit of a special case, where you'd have containers that are concurrently accessing and running warps on a single GPU. As of Kubecost 2.4, we don't have the ability to understand that, but absolutely in the future going forward, and hopefully in the near future, we will be able to understand some aspect of GPU sharing. It's a little bit complicated because when you start to go into sharing use cases, all of the same metrics that are available in concurrent access mode or that are in exclusive access mode are not available when you start to have concurrent access. So it's a little bit of a tricky situation, and we can easily go down a rat hole here, but net, yep, it's something that we're aware of. We'd like to have an answer around that, and we are looking into it.
To the end of our questions. Thanks, Chip.
Awesome.
This was fun. I even learned stuff, and I hope everybody else did too.
Yeah, same. Thank you so much to our speakers today, and thank you to everyone for joining. As you know, we mentioned at the top of the hour, I will be sending out a recording of this webinar as well as the slide deck to you all. I'll try to get it out today, but I promise I'll get it to you at least by tomorrow. And if you have any questions that you weren't able to ask, you're always welcome to reach out to us at team@kubecost.com. Chip was also kind enough to supply his email if anyone had specific questions. So I'll also send you his email address in my follow-up email. So if you have any, specific questions about GPU for your specific use case, or want to, maybe dive into more specific demos, we can definitely get that set up for you. But anyway, thanks for joining today. As always, it was great to see everyone, and I hope you have a good rest of your week.